Let us discuss about the quantum numbers. What are these quantum numbers? Let us define here. These are the numbers which are very much necessary to describe the distribution of electrons in the atom. We are going to call as the quantum numbers. And each electron in atom which is going to be characterized by the four quantum numbers. What are those? So they are nothing but the first one, that is called principal quantum number. Principal quantum number, it is denoted as the small letter n. So that is called principal quantum number. Second one, azimuthal quantum number or angular momentum quantum number or subsidiary quantum number. So it is denoted as the small letter n. So these are the second one. So third one is called magnetic quantum number. So it is denoted as a small letter m. And last one, that is the fourth one, that is called spin quantum number. So it is denoted as the small letter s. So let us discuss about the first one, that is called the principal quantum number. Let us see the points one by one. So mainly it indicates this principal quantum number. It indicates the main energy level or main shell to which the electron belongs. So this is a very important. The quantum numbers will be the pillars or the basement for the electrons filling in the respective orbitals. This is very important concept. So here it indicates the main energy level and main shell to which the electron belongs. So where the electron which is going to be belonging, so that is called the respective shells which is going to be studied by the principal quantum number. And also it indicates the average distance of an electron from the nucleus, that is called the size of orbit. Suppose if I take this an orbit like this, so this is called the center is called nucleus and this is called electrons. Electrons will be revolving around the nucleus, right? So that is called, it indicates the average distance of an electron from the nucleus, that is called the size of the orbit. Suppose this is an one orbit. If I take one more big orbit, that is also the distance will be vary, right? That is called the it also indicates the size of the orbit. And you know that the principal quantum number can be designated as the small letter word, that is called n. And when you are going to put the values as 1, 2, 3, 4 like this, so we are going to call this is the first energy level, this is called secondary energy level, this is third energy level, like this will be there. And this when n is equal to 1, we are going to call the shell. These are called n is equal to 1, the shell will be K shell. N is equal to 2, L shell, capital letter. N is equal to 3, capital M, like this will be there. So this is the lowest energy. This is the lowest energy and also it is the first energy level. What happens when N is equal to 1? What happens? This is the closest. This is the first shell, that is called K shell, which is the closest to the nucleus. That's why its energy will be very low. When the electrons, when the shell goes on increases, when the orbital goes on increases, as increase in the principal quantum numbers, the electrons which will be going to far away from the nucleus. Suppose if I take this one simple, so this is called first orbit, right? So this is K shell. I am going to call this as a K shell. If the K shell, this is called K shell. So what happens if the electrons will be there in the K shell, which is almost near to the nucleus? What happens if the value of n goes on increases, right? The principal quantum number increases, the electrons will be going farther away from this nucleus, like this. So this is called L shell. So what happens when the shell or the orbital which is going to be increases, as increase in the principal quantum number, the electrons which is going to be far away from the nucleus. So in the first shell, the electrons will be nearest to this nucleus. What happens these electrons? These are the farther away from, like this. When the value goes on increases 4, 5, 6, then the electrons which will be going to farther away from the nucleus. In general, the value of n, I told that the value of n, that is principal quantum number increases, the electron goes farther away from the nucleus and its energy will be also increases. The shell increases, the electrons which will be going the farthest away from the nucleus. The electrostatic force of, energy of attraction, so between the electrons, that is, they are inversely proportional to the distance parameter. So as the distance goes on increases, so the energy will be increases. So that's why this n is equal to 1. This is called the lowest energy level, whereas this n is equal to 4. Compared to 1, this is having the highest energy level. But this is the closest to the nucleus, which is the electrons in this nucleus of this fourth shell, which will be farther away from the nucleus. So, and one more important thing, the maximum number of electrons can be accommodated in any shell, that is equal to 2n square, like this. So if I take this n is equal to 1, right? If I take the n is equal to 1, that is called K shell, right? So in the K shell, how many electrons will be there? If I put n is equal to 1, that is called 1 square. 1 square is nothing but the 2. So there are, what happens in the K shell? Maximum 2 electrons you are going to fill here. So that's why I have placed only 2 electrons in the K shell. So if I take n is equal to 2, if I take n is equal to 2, substitute here, n is equal to 2, that is called 2 square, 4, 4 into 2, 8. I mean, L shell containing the 8 electrons. So, and I take this L shell, 1, 2, 3, 4, 5, 6, 7, 8. And the value of n is goes on increases. So the electrons also can be accommodated, that is also increases. Like this, n is equal to 3. That is called next M shell. M shell contains the 3. 3 square means 9. 9 to the 18 maximum electrons can place in the M shell. So like this is a brief concept of the principal quantum number. Let us discuss about the angular momentum quantum number or azimuthal quantum number or subsidiary quantum number. So that is designated as a small letter L. So here it indicates the sub-energy level or the subshells. We are going to go to the subshells. And the principal quantum number tells main shells, and azimuthal quantum number tells subshells. And it describes the shape of an electron orbital and angular momentum of the electron. It mainly tells the shape of an orbit. For a set of the value of the n, for the value of n, that is principal quantum numbers, L can have the maximum, that is possible whole numbers. It starts from the 0 to n minus 1. So these are called the subshells or sub-energy levels. So here subshells respectively 0, it indicates the small letter s. 1 indicates the small letter p, 2 indicates the small letter d, and 3 indicates the f. So these are called the subshells. So here what happens, if I take the principal quantum number value, that is n is equal to 4. If I take the value n is equal to 4, so what will be the subshells? For the main shell, value is equal to 4. What will be the subshells? So that tells that n minus 1, L is equal to n minus 1 is, we are going to take the minimum up to 3, 0 to 3. It starts from, because it starts from 0 up to end here, that is n minus 1, n is equal to 4, 4 minus 1 is 3. So like this, the n is equal to 4 means the value comes 0, 1, 2, 3. So like this, we are going to call this one azimuthal quantum numbers. And also S indicates the spherical shape, P indicates the dumbbell shape, and D indicates the double dumbbell shapes. So these are the shapes, because it explains also shape of an orbit, right? So here this is a set of designation. We are going to go here. So this is the indication of the principal quantum number, and this is the azimuthal quantum number, and subshell notation. How we are going to write these orbitals? So for the value of n is equal to 1, right? If n is equal to 1, what is the maximum value is equal to? Maximum value, that is n minus 1. What is the value of n? 1. 1 minus 1 is 0. So that starts from 0, ends with 0. So only it has the L is equal to 0. What is the subshell notation here? N is indicates the principal quantum number. So n is equal to principal quantum. This is the principal quantum numbers. These are. So what will be L? L shell means 0. 0 means it is designated as the S subshell. Like this is called 1s. Similarly, if I go for the principal quantum number, that is n is equal to 2. N is equal to, put here, 2 minus 1, that is 1. So it starts from 0, 0, 1. Only maximum 2 subshells. So that is principal quantum number 2. For 0 it is designated as S. For 1, that is 2 is common for this one. 2 this also represents this one, and 2 also represents for this 0. That is called principal quantum number 1 designation as a P. Similarly, if you go for the principal quantum number 3, what will be the maximum value L? That is 3 minus 1, that is nothing but 2. Starts from 0, ends with the 2. 0, 1, 2. So this value will be same for this one, same for this one also. So this is the principal quantum number. These are the subshells. 0 for S, 1 for P, 2 for D. Similarly, n is equal to 4. We are going to get the maximum as L value of 3. So it starts from 0 because of the 4 values. 4 is the principal quantum number, and S, P, D, F is designated as the 0, 1, 2, 3. So this is a brief concept about the azimuthal quantum number. Let us discuss about the magnetic quantum number. It can be designated as M or ML. So here it describes the orientation of the orbital in space. How the orbitals can be oriented in the space, that is going to tell about the magnetic quantum number. And the value of that ML, I mean magnetic quantum number, that mainly depends upon the value of the azimuthal quantum number. So let us explain how it is going to be depend here. So then for a given value of L, the ML are minus L to plus L. In order to find out the magnetic quantum number, it mainly depends upon the azimuthal quantum number L. So that indicates the minus L to plus cell, and between minus 2 plus in between 0 will be there. So that is also included. And giving the total of the 2l plus 1 value. I mean, in order to find out the magnetic quantum number, this is the formula. Ml is equal to 2l plus 1. So let us discuss here. This is the formula. Ml is equal to 2l plus 1. If we substitute the value of 0 here in this formula, if we substitute the value of 0, then what is the Ml magnetic quantum number should be? So that is equal to 1 only value will be there. So 1 is nothing but the 0. So hence total value should be 1. So then L is equal to 1. If I substitute here L is equal to 1, what happens? 2 into 1, so plus 1, that is called 3 will be there. So 3 values will be there. That starts from minus 1 to plus 1 including 0 value. So 1 is nothing but the P. So like this, so these are the subshells, their designation of the subshell. If L is equal to 0, S, 1 P, 2 D, 3 F, 4 G, like this will be there. So values also, when you substitute the values of L here, you are going to get the values as Mn. Suppose if I take the L is equal to 3, that is called F subshell. What is the value of 3 here? 2 3 is 6 plus 1. Total 7 values must be there. That is 1, 2, 3, 4, 5, 6, 7. Because it starts from minus cell to plus cell. When I take the value as L is equal to 3, means it starts from minus 3 to plus 3. In between, how many numbers will come? You should write here that called the total numbers of the magnetic quantum numbers. Let us discuss about the last quantum number, that is called a spin quantum number. As the name indicates, spin. The electron will be spin around its own axis. So if you take the solar system, the earth is revolving on its own axis along with that is also revolving around the nucleus, that is called sun. So like this also spinning will take place. The earth spinning will be along its own axis. Along its own axis it is going to revolve around the sun. So like this also here the spinning of electron takes place. If it is in clockwise, that is we are going to call as the plus of. If it is anti-clockwise, that is called minus of. So let us discuss about this chart. So here we are going to study the whole set of the 4 quantum numbers here. So starts from the principal quantum number 1, that is called N. N is equal to 1, that is called the main shell, K shell, right? So main shell, K shell is, then what is the value of L? L is obviously 0 because N minus 1. N minus 1 is equal to 1 minus 1, that is called 0. So what will be the designation subshell? So 1 is nothing but the main shell, principal quantum number, and 0 will be 1s. We have studied already this one, right? So next thing is Ml. Ml values will be for L is equal to 0, the Ml value will be also 0, and the Ms will be the electron. That is I told that plus of minus of. These values cannot be changed here. Plus of minus of values will be there. So total number of electrons in the subshell will be how many electrons? 2 electrons will be there. So 1, 2 electrons. So 2 electrons. So total number of electrons in the main shell is 2. So second one, main shell, that is called N is equal to 2 is main shell, that is principal quantum number. So value of N will be N minus 1. 2 minus 1 means 0, 1. These are the values. So respectively 2 and SP. For 2s, it is values will be 0. For 2p plus 1, 0 minus 1. Because of the N is equal to 1, right? Ml can be start 3 values will be there because 2L plus 1. When you substitute the value of L is equal to 1, that becomes 3 values included 0. So our plus of minus of plus of minus of. This is the constant. So count the number of electrons and subshells. How many for this 2s orbital? Only 2 electrons. This one electron, 2. So here 2, 4, 6 for the 2p orbitals total. When you add these one, 2 plus 6 becomes total number of electrons in the shell. Last one, principal quantum number 3, that is main shell, M designated as M. So L values will be 0, 1, 2. So because N minus 1, 0, 1, 2. So these are the respective 3s, 3p, 3d orbitals. In Ml values, 3s will be 0 values. So having the plus of minus of, that is 2 electrons. Total number of electrons 2 will be there. In 3p, 3p means L is equal to 1. 1 means p indicates. And 3p for Ml values will have what happens? The Ml 2L plus 1 values. So that is 3 values will be there. 1, 2, 3 plus 1, 0 minus 1 plus of plus of. So this set of will be total 6 electrons will be there. So like this for L is equal to 3d will be there. So designation for L is equal to means 2L plus 1 value gets the. It starts from plus 2 plus 1, 0 minus 1 minus 2. So each electrons means plus of minus of plus of minus 1. That is what 1, 2, 3, 4, 5. So 5 to the 10 total number of electrons. When you add these ones, that is called 2 plus 6, 8. 8 plus 10, 18. So you are going to get the total number of 18 electrons. Then how to cross verification? How you are calculated whether it is right or wrong? So So that is a simple formula, that is called 2n square. This is the formula to find out the maximum number of electrons can accommodate in initial, that is called 2n square. Substitute here n is equal to 1. N is equal to 1. So what happens? N is equal to 1. We are going to get the value as n is equal to 1. So that you are going to get the 2 electrons, maximum 2 electrons. That's you have cross verified. Similarly, n is equal to 2. N is equal to 2 here. So what is the total value? 8. So substitute here 8. 2 square 4. 4 to the 8. Yes, we have corrected. We have done correct. Right? So next, n is equal to 3. Main shell 3. So how many total electrons you got here? 18. So n is equal to 3. What happens? 3 square 9. 9 to the 18. So like this, the maximum number of electrons can accommodate in shell. That is using this formula. We are going to calculate this one. So this is the spin quantum number. So we have studied all the 4 quantum numbers.